For today's post, you're going to get a little mini stats lesson just because I'm going to need to explain one of the dilemmas that I've been having. I'm not going to go into too much detail, but I just kind of wanted to throw this out there and see if anyone else had a thought on this situation that I'm in. So I was considering calculating Cohen's Kappa, which is a very common use for inter-rater reliability, particularly for behavioral observations. But what I've found is what I'm doing is a little bit different than how Kappa is traditionally used. So first I'm just going to show you a little mini lesson on how Kappa is supposed to be used. And then I'm going to show you why this situation is a little bit different and why I've chosen to use a different measure of inter-rater reliability, which is not considered as good as Kappa by most statistics textbooks. But I think Kappa may be inappropriate for my situation. So I'd love to get anyone else's feedback. Or if you have no idea what I'm talking about, that's fine too. I just think I will present this either way. So right now I have my iPad projected up just so I can draw a little bit and show you. So this is the basic formula for Cohen's Kappa, and all it's saying, this first part here, oops, I'm drawing lines. Help if I would actually have a marker up. Okay, so this first part here is the probability that of the agreements that we have. Then this second part here is the probability that the two raters might agree by chance, because there's always, if you have a set number of observations and say we're rating them as yes or no, there's always a chance that we might have both picked yes for a certain incident just by chance. So Kappa takes into account this chance that a lot of other measures of inter-rater reliability do not. So in this basic formula, we essentially have just the probability of agreement minus the probability that we pick the same thing by chance, and then we divided it by 1 minus that probability by chance. I'm not going to get into detail about that formula or how to calculate that probability by chance because it's a little tricky. But I just want to show you what something might traditionally look like. So say this is 6 observations of somebody's grades in a class, okay, or textbook. So these are each one of these sets of boxes would be somebody's specific observation. I have rater 1 and rater 2. And we're each going to rate something as passed or failed. So rater 1 might say, this person passed, failed, passed, failed. Rater 2 might say passed, failed. Okay, we can see right here that there is a disagreement. But how would you calculate this inter-rater reliability when it comes to that? Ideally, you want that behavioral observation definition to be so good that your raters are going to rate it the same way. That's what reliability is. So I have one difference here. So what I could do is I could total up the total number of agreements, and we have 1, 2, 3, 4, 5 agreements, and the total number of disagreements, and there is 1 of those that I circled, 1 disagreement. Now, as part of the calculation, you put your results into a matrix. I'm going to draw. This is the most simplest of cases because there's not a large n, and there's only 2 choices. This gets much more complicated when you have more than 2 categorical choices. So basically, if I have this as rater 1 and this up here is rater 2, they each had pass fail. So I can start marking down the numbers that we both said passed. So if I'm looking at my little side thing, there's 1, 2, 3. There's 4 cases where we both said pass. This would be where we both said fail. There's 1 case, and then there is 1 case where rater 1's okay. So 1 here and 0 here. Okay, that's as far as I'm going to go. There's a whole lot of calculations you make with rows and columns, and you create, percentages and things like that. But as you see, I have to be able to put this into a matrix to do some of this. So I need to be able to have not only the percent agreement where we both said said 1, I also have to have a percent agreement where we both had another choice. I'm not explaining this very well. I guess if this was yes and no, like I'm going to show you in just a moment, I want to know, was the student receiving assistance or was the student not receiving assistance? Yes or no. But the problem is, you're going to see in a second, I didn't have a set number of instances. We can have agreed upon instances where we both said yes, but there's no way for us both to have said no in that case. I can't get those agreements because I didn't have a set number of observations that we both looked at. So this is the issue I'm having. Let me just turn this off and I can show you a little bit easier on my actual screen. 1 second. Turn that off. Should turn my mirroring off. Okay. Now, so we're looking here. These are the places where I'm going to be calculating some inter-rater reliability. And if we look back at my code window here, okay, I can look, what I'll be actually calculating are the number of incidents that overlap between rater 1, which is this here, and rater 2 here. So I'm counting up, okay, there's 1 overlapping instance, 2 overlapping instances, and 3 overlapping instances. So we agreed, not only did we both say there were 3 incidences where students asked for assistance, they were at the same time, they were the same instances. Even though they might not be the exact same duration, we were counting the same instances. But as you can see, there weren't any instances where we both said, no, they were not. I guess it's all of these empty times, but because the durations aren't the same, that doesn't quite work. It would work for like an interval recording, but it's not exactly the same thing. So when I'm calculating that little matrix, I don't have any no sections, if that makes any sense. So in this case, I'm not sure if Kappa is the most appropriate because I don't have a set number of observations. Okay, I can get a total score by saying, say we didn't agree all 3 times, and he had 1 extra instance over here that I didn't have. Okay, so then it would be 3 out of 4 total instances that we agreed. So I can do a % agreement, but I'm not sure that I can do Kappa because of that missing piece. I hope I explained that well enough. But I will show you what I did do instead. Rather than just a plain old % agreement, I'm going to hit execute here first. Okay, so I can see that I said 3 times they asked for assistance and 3 times they received assistance. And if I looked on the other rater's code window, I would see that that person also said 3 and 3. But the key was I needed to make sure we were counting the same exact incidences, not just 3 and he had 3 that were different than mine. So I have to look at a point-by-point % agreement. So I'm actually looking at the overlap, not just the numbers themselves. So that's what I have put here. So for inter-rater reliability, instead of Kappa, because again, I'm not even sure if that's appropriate, I even asked my statistics professor, and he wasn't sure. Because Kappa is much more used in, sometimes in behavioral observations and like single case design. So he wasn't even sure because it's kind of a unique case. So point-by-point agreement here, will show you my my scripting window so you can kind of see what I did here. I have, I've set my variables like I have been doing in the past. I found it's much easier if I set variables first before I start plugging in formulas so that it doesn't get so complicated. My agreement, this is an important piece to note here. I'm going to separate things out so you can see it pretty well. All right. When you first count overlapping instances, like I was pointing out in my other window here. So from here to here, I was counting these instances that overlap. It actually counts those as 2 rather than 1. So it counts this one and this one for the overlap for some reason. So you have to deal with that when it comes to your formulas, and it's a very simple fix. So I have this here, this is a shortened version of agree, to count those overlapping. And then you just have to divide it by 2 because we're counting the overlap of 2 people. That will give me the exact number of frequency for agreements. And then I have, for the other rater, whose name is Dane, I had, his was any instances where he asked, okay, I was looking for instances where Dane coded something, but I did not code that. So in order to find that, I just said, the number of times, count the instances in his row, and subtract the agreements. So if there were any extra ones, I would find out how many. And then the same thing for mine. And then the total would just be the number we agreed, plus the number that was just Dane, plus the number that was just me who coded them. And then a very simple formula for this point-by-point agreement. The overlap is what makes it point-by-point. The inter-rater reliability is just the number of agreements out of the total times 100. That simple. And again, it doesn't take into account that % error by chance, but that's where I don't know that it's the same thing. It's not the same as yes, no, like your odds are like 50% maybe of picking something by chance. It wouldn't be that in this case because it's out of a whole long duration of a period. So that percent error calculation is probably not the same in this case. That's just what I'm speculating. So just to be safe, I'm going to do a very, very simple inter-rater reliability calculation here. And then I presented it by rounding it and adding the percent time, and I put a whole phrase in here. So inter-rater reliability equals, and I rounded it to 0 decimal places, just for simplicity. So when I hit execute, you could see here, we were 100% in agreement for these two measures here. And over here, those didn't change because that is for my third coder, who I have not imported his data into here. I'm trying to make this window very useful for me in the future, so that no matter, we can all just code all the videos we're supposed to, and then I'll just import whoever double coded with me. I'll import that person's, and then I can calculate immediately the inter-rater reliability, no matter which person also coded with me. So that was a very long ramble, but hopefully you kind of understood where I was coming from, but this is where I am so far. Tomorrow I'm going to talk about this piece here or tomorrow, maybe the next day when I make my video, I'm going to talk about a new way I've learned to use some scripting.